Hello everyone, I'm Mäsak. This is a talk about regexes and grammars and which one is which and why and how. Everything is a string and can be manipulated with a regex. This is sort of the starting point of Perl, I feel. There's a resource out there talking about the different levels of Perl mastery, and sort of level 4 out of 7 is this: everything is a string and can be manipulated with a regex. Everything is a string and can be manipulated with a regex. It's a nice starting point, and I've learned to live by that idea and use Perl, mainly Perl 5 in that way. It's nice to have an overriding idea like that. For example, Lisp has everything is a list, and you sort of run with that idea and do various things with it. We have Smalltalk, where everything is an object, even things that are not objects are objects. And then we have PHP, where everything is a security exploit. It's nice to have such an overriding abstraction in your language. And actually, I think Tickle probably wins on everything is a string. They do that even more extremely than Perl does. Perl is a little bit too multicultural to go all the way with everything as a string. But you can still treat it like that, and many programs come down to, okay, we have some input that comes in, it's textual data, we do funny manipulations with it, and we have some output that goes out, and it's also textual data. Even the name Perl, if you think about it, practical extracting and reporting language. Those extracting and reporting are sort of the endpoints of your process, what you're doing at the endpoints of your program. And Perl 5 is more everything is a string to be processed, sort of the extraction thing and then you process things. And with Perl 6 I have a slightly different feel for what you do, and we'll go very much into detail in that. Where everything is a string to be handled by a regex, but sometimes it's easier than that. Sometimes it's just substring or unpack or whatever. So my thesis today, this view of Perl, this view of programming in general, is very good and it's very bad. And it's always difficult to have a double message to the audience, but this is the easiest I can get it. And you'll see it's very good from people who don't have this view, who actually go and implement that 200-line C++ or Java program to extract names from a phone book or something like that, where you simply, all you're missing is the idea of regexes, so you can do it in 5 lines instead of 200. And it's bad because of some things that people do when they love regexes and they just go too far with them. Including me, and we'll see examples of sins that I've committed in this area. So a quick, or as quick as you wanted, Perl 6 regex intro. By the way, I should say I see different kinds of people in this room. I see this contingency here, which is basically people who are only here to troll me.
I need to admire you.
And then I see lots of other people who I suppose are interested in regexes and grammars and maybe even Perl 6. And let me just run through a quick syntactical introduction to what's changed over from Perl 5 to Perl 6. And there's a lot more going on beneath the surface with semantics and so on, but it's good to start with the syntax and to talk about that.
We're just in here because we don't have to pay attention.
There you go. This is a nice place to relax and think about something else. So a lot of things are the same between Perl 5 and Perl 6. We're not just changing things around because of the fun of it. We're changing things around which need to be changed. So up here in this corner are things which remain the same. You see they're the same on both sides of the arrows. Now there will be some subtle semantic differences somewhere, and the hecklers are free to point that out. For example, here I wrote Unicode because we're now matching on Unicode letters and digits and white space by default.
That's true by default Perl 5 too.
That's true by default Perl 5 too. Okay. I thought it depended on locale and things like that.
Not by default.
Okay. So you managed to convince them. I know you had discussions about that.
Well, I just made it that way first, and they didn't want to change it.
Okay, excellent.
Them being Perl 5 people.
Right, so the Unicode actually goes on
Actually,
both sides here.
they didn't dare.
Right, there you go. I guess everyone in this room has heard about the two rules. So rule number 1 is Larry is always right. And rule number 2 is when Larry changes his mind, he's still always right.
Yeah, that's the more important of the two.
Right.
Larry was always already right.
Right, there you go. We're retconning as much as we can. And you see alternations, they're the same syntax, slightly different semantics, hand wave. And if we want to escape things, we can still use the / character here. There are things which changed. For example, when you talk about captures that you did, so you captured something in parentheses, and now you want to use it, and they're in these special registers or variables. They used to be in $1, $2, $3. That turned out not to work that well in Perl 6, because we're actually treating this as a list of things. We're indexing, and lists tend to be indexed from 0. So we had to rename the first one here to $0 and just shift everything down one step. So what used to be in $0 in Perl 5, anyone know? Yeah? Program name. It's now in a variable called program name, which makes a bit more sense, I think. There's also the / variables here. They're used inside of the regex itself before you sort of left the regex. This was so difficult to keep track of. When would you use the $sign and when would you use the /? And it didn't really matter. So we just got rid of the / for that use. And now instead you use the same variables there instead. There's a lot of hysterical reasons behind syntax like this. And we're leaving much of that old syntax behind because we can. For grouping things, so you want to pull several different things together and treat them as an atom, as it were. If you just have a single character, you don't need to group it, but if you have several characters like foo here, you have to group it in some way in order for the regex to treat it as one unit. Now you can either quote it, at least in this case, when it's just a string, or you can put these square brackets around it. Now square brackets used to be character groups, and we now have a slightly longer syntax, not shown on this slide for some reason, for character groups. There's also, you use quoting either when you want to escape things or when you quote things like this. So there are several different ways to go about it. You can still use the old escaping mechanism like this, or you can use literal strings in your regex. It's quite nice. And all these quantifiers, basically things that we associate very heavily with regexes, they stay the same with 0 or 1, 0 or more, 1 or more, they're just the same. And these slightly less known forms with frugal quantifiers, which take as little as possible. They're not greedy like their cousins. They also stay the same. But there's one quantifier that changes, and this is sort of the fourth quantifier. You want to match n times, like 7 times, or 2, 3, 4 times, or 5 times or up. Now we had a better use, as you will see, for the braces here, so we just turned this into ***. It's a bit like exponentiation outside in the real Perl 6, in the big Perl 6 language. That's kind of nice. And in any place where Perl 5 would use ranges and write them with a comma like we do here, and here's even sort of half a range, you don't even have anything on this side, we write it with a real range, and that same goes for character ranges as well. So no dashes, no commas, we just write it consistently across the whole language. There's also one thing that doesn't have an equivalent in Perl 5 at all. There's this quantifier modifier here. So we're saying, yes, we want to match several A's, 1 or more A's, but we want them to be comma separated. So we're saying basically, yeah, several of these, but with these in between. So the % here is to be read as, how do we actually do the quantification? Well, we allow things to be in between.
You can actually read it as modulo if your mind bends modulo that way.
Right, true. Yeah, so several A's modulo the stuff in between, the commas in between. I think I will actually demo this because I heard some whoops in the audience. So this is going to be quite a live demo heavy thing. And we have...
I think that was me. I was mostly just because I had never thought of star as being a kind of exponentiation before.
Oh, okay. I heard a whoop on % as well. So we have this string here, and I can type up or down, which will be interesting. And I still don't have RL wrap, sorry. And we make one of these matches. If we just match on several word characters, what will we get? Well, we will get a match which is like this. And we can group that one, like that, and say, yeah, we expect one or more of those, but with commas in between. And here's where I put the comma in quotes. And it will match that whole thing. And even if I want to capture that, so the brackets are non-capturing and parentheses are capturing, I can get this out as a capture group as well. Just say, yeah, the words that we're interested in here, just capture those like that. And each one will end up in $0 here. It will actually be a list of the captures that it found. Now that's one of the things I'm not mentioning on this slide, just showing the syntactic transitions. When you've made a match in Perl 5, what you get back in all these $1, $2, $3, they're just strings. They're just the substrings of what you were matching. In Perl 6 you get back real objects. They're called match objects. And they can be strings if you want to, but they really contain the whole structure of the match that you match. And that will turn out to be really important when we go on to grammars. What else do we have? We still have case insensitive. We have global matching. They're exactly the same, but you will notice that the modifiers now go up front. This is a general decision because in Perl 6 we tend to put such information early. One of the problems with Perl 5 regexes is that you don't know exactly how, the parser doesn't know exactly how to parse the regex before it reaches the end and sees all the modifiers. And in Perl 6 we prefer to know which language we're in, which language we're parsing. Those of you who have dug into regexes know that if you want to include a literal string in a regex, you have to do this playing around with \Q and \E to say this is a literal thing, this is not a regex. Otherwise you will be susceptible to injection attacks and so on. People will abuse your regexes. And that doesn't happen in Perl 6. We just use the variable directly and it will always be safe, which is nice. Now the question is then, how do you get this unsafe behavior if you actually want to include a regex in another regex? That's also easy. In Perl 5 it's too easy, but here we surround it in angle brackets, and then we say, yeah, use this as a sub-regex.
It's simultaneously too easy and too hard because it's not actually,
right.
It's actually doing string interpolation and then reparsing it.
Right.
Yeah.
So let's say in this case, this is a small regex here. I could call it word or something, my word, and just include it there. And I've saved it away, sort of. If we look at this object, we see that it is a regex object. So that little hat there is saying this is not a real method on the object, it's a method on the meta class that cares about the object. And now if I want to redo this and just include word here instead, I put it in angle brackets and I do the rest the same. Like that, and it still works. So that's very powerful. We can still build up bigger regexes from smaller ones. If we want an assertion in the middle of the regex, so basically drop back into Perl 5 code, we do this in Perl 5, and it's become much, much easier in Perl 6. Here you see what we did with these curly braces that we freed up from this part. So now we can just, here's some programming language that we want to run in the middle of the regex. Sometimes we're interested in the result as well. We want to say, only continue matching with the regex if the code that we ran here is true. Then we use this angle brackets but a question mark. Or sometimes we want to say only continue if it's false, then we use the angle brackets with the exclamation mark here. So that's kind of nice. And the E modifier is completely gone. We no longer treat this side specially and evaluate it, and we no longer do this horrible golfy hacky thing with double E's and triple E's and so on. Instead, if you want code in there, you just do this trick up here. So you just include code there, and it will be returned as part of the regex. And what else? We no longer have this S modifier, which modified the behavior of the dot, saying the dot no longer matches everything except for the new line code point. It now matches everything. So the S is simply implicit in everything. Same with the M modifier here. The M was used to modify these start and end anchors to be about lines. And that's also implicit. Now you just use special start and end anchors for lines instead. They're doubled because they're slightly less common. So, yeah.
The logic is that it will match multiple times.
Right.
Multiple places in the string.
Right. Exactly. And then you have these two, and they're completely new as well. There's no corresponding thing in Perl 5. You can definitely do the corresponding things, but not with syntax. It's easy. So I found a typo, but only the second one is actually a typo. So I only want to fix the second one. So I have a modifier here saying second. Now, how does that work? Well, it turns out there's an ND adverb, and it takes a number, and I can pass in 2. So second, if we clear the screen here, second like this is actually syntactic sugar for ND2 like this. And there's also first, and there's third, and that's it. That's the whole set. So this.
And the obvious question is, yes, you can, but don't do that.
Like that, yeah. Yes, you can, but don't do that. It's freedom under responsibility, of course. And we can also substitute a number of times if we want. So this one runs through things 4 times, and then it stops. So it's like a subset of the functionality of global matching. This one knows exactly how many times to match. Okay, great. Any questions so far? I plan to show much more of Perl 6 regexes as we go along. So, my thesis again, regexes work. They're wonderful. They're even wonderful in Perl 5 despite the slightly quirky syntax. They're awesome. They let you do your work and sort of get in, solve the problem, and get out again. And that's all we want. But they're not nice. The syntax is heavily burdened by history, and it's like you can overuse them, and people tend to overuse them. I often overuse them, and that's why I'm standing here today. So do regexes by all means, but switch over to something better, grammars, when it's time. So here I go out on a limb and show you some production code that I wrote for work. And I will show you the contents of this for loop. I didn't put it all on a single slide because it doesn't go on a single slide.
Is this long as give me 5?
No. This is a small example. This is just enough to disgust you. And that's the idea. So maybe you've seen this trick here. We take a text and we just make it the $_. So this is like a poor man's given, really. It works even in older versions of Perl. It loops over a single thing, and inside of this loop, the single thing that we're interested in is called $_. So here's my code. This, by the way, is a C# syntax color highlighter. So it finds keywords, like new and class and public and private and protected and interface, and it gives them some color. Incidentally in LaTeX, so these are LaTeX macro-like things. Now you may look at this and say, what? This is kind of hard to read. This is the modem noise your mother warned you about. Don't go near Perl because it looks like this. But it works. I mean, this was a one evening hack. I maybe spent an hour on it or two, and it got to syntax highlighting all I wanted. And it goes on for another page like this. And again, it's not nice. And here it starts to actually fall apart, which is one of the interesting things. We can do nice things like actually have checks in here. The eq any here is sort of a back borrow from Perl 6. Just check if what we matched here matches any of the keyword types. But we also have to scrub the regex. And why do we have to do that? Well, because we can have several nested matches. So we can have coloring that goes on in a small part, and then we have coloring that goes on in a bigger, wider part. And then we need to scrub the inner color. So we need to actually go back and cover our tracks and undo the things that we already did. So this scrub here is the first symptoms of us going crazy with this code.
What language are we in now?
This is Perl 5 all the way.
No, I mean.
Right, okay. What language are we in? Yes, that's the problem. That's what Larry touched upon. Basically, between each of these lines, you have to read between the lines. We're in a slightly new language where we're sort of partially syntax colored. And that hurts. You're creating 20, 30 languages here just on the fly. You shouldn't do that. It's not good for your health. And you see here we're actually desperate enough to use the eval flag as well. Not that there's anything wrong with that. Still, this works. And I wanted to show you the Perl 6 equivalent of this, sort of a C# syntax highlighter for Perl 6 with grammars, with real things. But I started in on it and I realized it's not interesting enough for a talk, so I thought I would do a live demo for you instead, where we just live code a chessboard. So what do I mean by chessboard? 1, 2, 3, 4, 5, 6, 7, 8. Copy like this. And we have pawns like that. And we have a queen and a king somewhere, right? Some of the hecklers let me know if I got them in the wrong order there. I bet someone knows.
Are king and queen in opposite orders on both sides?
Thank you, sorry. Oops. Yeah, it felt wrong. So king, queen. What else? Any takers? Rook. It's got to be an R. Right? And knight. Good night, Perl 6.
Usually with an N.
Oh, you're right. Yeah, we should be standardized here. And I'm missing what? Bishop. That has to be a B, not an H or anything.
Why are you using S instead of R?
Sorry?
It's heckling your VI.
Oh, okay. I have no idea. I've never used R. Okay.
It might be useful to I don't know, make case distinctions. You can tell what pieces are black and what pieces are white.
Oh, that should be easy.
That's would be tilde command, I think.
Yeah. Here we go. And I can do it for a single word, but it will just be quicker to do it like this. Tilde. Did I do it for the right side?
No.
No?
That's okay.
That's okay. That's okay, but it says perfectionist on my name tag. Now, because this is Perl 6, I would start like this. Enum, state, and things can be in different states here. They can be empty, or Texas, yes, or pawn, or rook, or knight, or bishop, or king, or queen. And I'm making no distinction here between black and white. I could probably do this in color. But let's skip that. This is good enough for our example here. Now we want a syntax to parse this. So we need a grammar. chessboard. Let's do that. And at this point, whenever I'm writing a grammar, I have to stop myself here and prevent myself from guessing how this grammar will look and sort of trying different things out. The first thing I should do is to write a test. So use test and say is chessboard parse, and we're just checking. Thank you. And we're just checking that we can parse this at all. That's a good start. So I'm taking this string. Actually, it's probably better to move that one up here.
Does Rocker don't have ear dogs yet?
2, 3, 3. Oops. There we go. And since I'm only interested in did it succeed or not, I actually can do an OK here and just take the Boolean value, not really necessary, say it parses. Let's run this. All 6, chessboard. Does it parse? Oh, preceding context accepts. Oh, I shouldn't have added that equals there. That was just a... There we go. No such method top for invocant chessboard. Well, we can fix that. A grammar should have a regex top or a rule top or a token top, just so it knows what to do. And we put something in there because empty regexes are illegal. Okay, it parses.
Well, it shouldn't under current spec.
Yes, it should, because it has a beginning. And I want to be able to parse any chessboard. It doesn't have to look like this.
By default now.
Oh, that's true. So let's see it fail once. There we go. Oh, I see what you mean now. The current spec says that you shouldn't have to put in these beginning and end. But I see great confusion there, even in the spec and in the discussions about spec.
That's a reason.
Yeah. So now let's try to make this pass. And we use what we learned from this conversion table here. We can call regexes from each other inside of grammar. It's very easy. It's just using this syntax here. So I'm calling a rule that I haven't written yet. It's supposed to be down here, regex line, and it's supposed to contain something that we put in a while. But I don't want just one line, right? I want 8 of them. So I use this quantifier here saying, give me 8 lines. Okay. And what should the line give us? Oh, and I might as well use this nice thing here saying the lines should be separated by new lines.
Separated or terminated?
Separated. If I also want the possibility of terminated, I can use the double % here, which out in the real language says this should be divisible by, but here we borrow it for there can be stuff in between, and there can be one at the end as well. So we can have comma-separated lists with forgiveness for a comma at the end, which is really nice. Maybe we should use the terminator here, because then it's more forgiving. And here we have just places, and they should also be 8 of them. And we don't separate them with anything, because they're right next to each other. And just to parse this here, we need something that parses a dot, regex. Oh, and this should be in singular, I think, place. How do I parse a dot? Yes, thank you. How do I parse a dot here? What do I need to put in? It's not enough to just put the dot, though that would work in this case because the dot matches everything, but that's not what I mean. I mean something like this. I could either quote it like I did here or escape it. So thank you hecklers for catching this initial white space here, because I started here with a new line. It just makes things line up better. So do we expect this to parse? Not okay. So not okay.
Lessons on IRC comment you have 9 lines.
Thank you. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, that wouldn't parse, would it? So just delete one here. And thank Flossens on IRC. Yay! I should program like this every time with an audience of a few dozen. Right, so now we have our essential framework up here, and you see it already caught a bug, and that was totally not intentional. And what we just need to do here is we generalize this one. We could call that one empty instead, and empty, and use our place here to actually put in types. Place, it could be empty, but it could also be a number of other things. And now, just to take the whole step, maybe I would do it in fewer steps if I had more time. Let's just copy this here and put in our original chessboard. And let's parse all the things in one go. There we go. This is what I want to parse. Yes, that looks right. And if we run this test, it doesn't pass. Fair enough. Actual chessboard. So we need to fill in all the pieces here. So let's say can either be empty. Oh, and this is another nice thing. In Perl 5 I put the alternative pipe between alternatives. In Perl 6 I'm also allowed to put it before the first alternative. Why is that? Well, it reads nicer when I have several lines like this.
And we disallow null regular expression.
And we disallow null regular expression, so there cannot be anything before this. It cannot be misunderstood. And now we just need to fill them in, like in the state here. I can even copy this one and make sure I get all of them. There we go. And for each of these, I want to substitute and put in like that. Nice. So this is a grammar being built up from scratch. I think I got that right. And we clone a few of these. Put a pawn, put a rook, put a knight, bishop, king, and queen. And I got one too many. And here we need
Line things up.
There we go. To line things up. Okay, fair enough. I know Damien Conway has this macro for that. I should have too. So pawn is P, right? And here I used the character group. Note that we stole the bracket syntax for just ordinary grouping. So here we need to use the character group. Rook. And I could make this all a case-insensitive match, but I bet that would come back and bite me when I actually wanted to distinguish between black and white. And knight was N, right? Bishop, king, and queen. There we go.
Colon I too.
Sorry?
You could use colon I too.
Yeah, indeed. But eventually I do want to distinguish between those. But yes, I could use colon I. And colon I works for the whole regex, or it works for just a part of it, for an individual group or for an individual rule or whatever. I think I'm going to stop there with the live demo. I just want to add that now I'm in a perfect position to actually use this information to hook in actions. So I can take the things that I matched here and, for example, match them up with the things in the enum state here and say, okay, we matched a pawn, so let's actually tie it to an actual pawn. So what I can get out of this full grammar match is a data structure, just an array of arrays with the exact right values already in them. So using the actions, I can go the final step here and do post-processing of the whole thing that I matched, sort of on the way up in the grammar match. Let's actually have a look at how this structure looks. If I, instead of running a test here, if I just run the parse and print it in the end, how does it look? Say parse, and I will print it through the gist function here, so I guess I'll get out something reasonable. Yeah, there we go. Here you see all the 64 locations on the board, and we sort of dig down. We matched on entire rows, and then we go into detail what's in each place on that row. And then in the middle, there's a lot of empty rows like this, 4 of them. And then on the other side, here's the pawn line, and here are all the other ones. So you see how this turns into an actual match tree, and we can do nice stuff with that. That's much more than we ever got from the regexes. That was the live demo. So remember, computers are awesome. Programming is meant to be tapping directly into that kind of awesome. And if things feel less than awesome, it's probably because we don't have the right abstraction yet. And you might be doing something that is so out there that no one has ever thought about the right abstraction. But chances are that people have. Yes?
Computers are also very good at spell checking.
Oh, okay.
That's the other failure.
That's the other failure mode, yes. So Perl grammars are there for you when you need them. Directly, yes, now I see the failure mode. Let's do this. I have time.
So cool.
Regexes grammars, slides. Find diarrhea for me directly. And I did it again, didn't I? Directly. There we go. Make presentation. This is a Perl script. Perl 6 script. Okay, it took a fraction of a second. Reload. Or it may not. Okay.
It's more than a fraction of a second to load.
I think it's going out to the Google cache looking for font files or whatever. There we go. Tapping directly. So, yay. So grammars are there for you when you need them, and they're really, really nice. And the question in the abstract was, which one would I use? Well, obviously, I'm still, in some sense, stuck in the Perl 5 mode sometimes when I just whip up a program of 20 regexes and they solve my problem for me. And that's fine sometimes, but I know which one I would rather maintain, and that's the grammars. When I have something like this structure that we ended up with this grammar, that's eminently editable in retrospect, and I can hook in new things here, I can hook in new actions, I can do various things with it, and it's very, very readable. It's not my 20 lines of regex. So there we go. Thank you. I believe I have some time for questions. Does anyone have a question?
Why are you so awesome?
Thank you, whoever you are. Should I demo some more regex features, or do you want to go home? More features?
More features.
What haven't we talked about?
More, yeah.
We haven't talked about backtrack control.
Right. Yes, you have a question, sir.
Yeah, is there a way to track character requests? So you can say, I want this character class, like I want
Oh, excellent.
R.
Right.
Yeah, very easily.
Yes, let's demo that.
That's one of the reasons for putting it into angle brackets.
So you can do, I want to match everything between A and Z, right? And this will match the F, the first F, because I only asked it to match once. And then I want to be able to say, yeah, do that, but no, I don't like Fs very much. So this syntax, like Larry said, it's like it's built for this kind of addition and subtraction. In fact, it's as if, oh yeah, and this original plus here, it's implicit, so I can just do, yeah, do the alphabet, but don't do Fs. And I close that one, and it matches the first O instead.
And you can even do angle bracket alpha minus bracket F.
Oh, indeed, that would be more like the Unicode way.
Require the plus.
Plus alpha minus, still don't like Fs. There we go. So it does it for both manually specified character group like this, or names of character groups that were already predefined.
And the second one will match any Unicode
Right.
Got a question about grammars.
Yes?
Is there any ability, rather than outputting a parse tree, is there any ability for it to construct objects of your own design in the process of doing that?
That's what I meant to demo with this chess thing. So we had this enum that we were just about to plug in, and what you do is in your action methods you just type make, and it says attach this object to this part of the parse tree. So generally we make a distinction between the parse tree, which is the direct product of what we get out from the regex match, and a syntax tree, which is what we actually want to get out, some sort of process things. And we go from parse tree to syntax tree with this make function. So just call make and attach whatever you want to it. And if you're wondering, well, does that actually work in practice? Yes, it does. Rakuda is built like that. Yeah.
Show one of the Perl 6 parsers.
Which one?
Standard.
Let's take the standard one, std, and it's in PM6 these days, right? So here's a really big, impressive Perl 6 grammar, and it specifies the Perl 6 language. And we're kind of very close nowadays in our implementations to following this one. And you can see, if you compare this to the corresponding thing in Perl 5, which would be toke.c, this one doesn't make you want to run away screaming.
There's still a star, even at the end of that big long block. There's still a star, and that's still a cleany star.
Yes.
And the plus mark.
So here you have things like, what's an identifier? Well, it's something alphabetic and followed by one.
We have the action method.
Identifier is
Right.
below that one.
Identifier is below that one, yes. Ident is some small thing. Identifier is all our Perl 6 variables and so on. So you see it can be both the original meaning of ident, and then we can have apostrophes, which is a funny rule defined as either an apostrophe or a dash.
This is the wrong grammar to show if you wanted to show action methods. So.
Right. Here you could have shown this nice percent thing. I believe I still have time to show action methods. Let's go into Rakuda instead.
The other place with action methods is out in JSON.
We could show that one, yes.
Rakuda tends to put them off into a different.
JSON is the simpler choice. Let's look at that. JSON tiny, and we have the grammar. Just take a brief look at that one. It's been shown in some other talk. Here we match objects, pair list, pairs, arrays, array list, and so on, and then various symbols which are true, false, null, object, array, and string. And if we go to the corresponding action class and see what it does with those, for each of those rules there's a corresponding method that takes in the match object as the parameter here and just does make. So here you have the make process. Attach this object to. So what do we do, for example, with an array? Here we have the array. Well, we go dig into array list and we just attach that as the object here. What's the array list? Well, that's where we actually make the array. We make the array as brackets here. So create the array and fill it with the actual individual values in that array list. So there we go, and I think I'm now officially out of time. So again, thank you.